Hey guys, this is my oral presentation on an algorithm called flood fill or seed fill. So first I want to start off by going to this Wikipedia of what flood fill is. So it's used, the basics is it's used when you use Paint program, you can click the bucket tool and you can uh, click on a color or an object and it will fill out from that same color to a different color. It's also used. Interesting facts. It's used in different games like Minesweeper or Go, the Japanese game, and it can even be used to identify paths out of a maze. So I thought that was pretty cool. Here, I'm gonna pause it. So as you can see, there's a little picture showing some implementation of it. There's two different ways you can implement it. One is north, south, east, west direction fill, and one is north, south, east, west, and diagonal directions as well. And that's why those two pictures are different. And so when we want to implement this, here's an example of what's happening. See, we got these pixels, and the gray pixels they wanted to turn to black, so they click on it with the paint tool, and they click on any node on there, and it changes it all to black. So there's a good implementation of it. So basically, what you need to implement this is a matrix. So a matrix with different colors on it, and he shows an example here. So he's got essentially this matrix in chars. So I was just kind of showing you how to do it with chars characters. And so essentially you just need to know the coordinates of where you're clicking, where your mouse is on the page, and then when you click on it, you have your replacement color, which he used C, which I guess means black for him, and then or gray, and then he clicks on it, and then he starts the flood fill algorithm. And there's two ways to implement this. One is a dynamic approach, and one is a recursive approach. And in the dynamic approach, you use a queue, and you just use a queue of a pair of integers, which are the coordinates of the x coordinates and then the y coordinates, so the row and column coordinates. And essentially, you push the first coordinate on, that is where you're starting, and then you just have a while loop running until it's not empty, and you just compute each one, replacing the matrix right here we see, and to what it's supposed to be. And then he has a for loop that he checks the surrounding areas, north, south, east, west, and he's doing. If you look here, he has some globals up here, a row, column, and it's looking at northeast, southwest, and southeast, southwest. Diagonals as well. So and he just pushes those on until when if he sees that they are that color that he wants to replace, he just pushes it on the queue. And so he's essentially doing a breadth first search instead of a depth first search, which would happen with recursion. So that's how he implements it here, and eventually he'll fill all those with the right color. And then what we have in the other one is a depth first search approach. And in this one, what he's going to do is he's going to use recursion. So the only difference, it's a lot less code. Obviously, that's why we like recursion, is less code. But he's got that matrix. He's got the starting node again. He's got his replacement color, and he starts it. And what he does is he has the target, and he changes the color of the target. And then he checks again the outlying and sees if they're the target color that he wants to change. So he's got that target color he wants to change, and then he looks and he uses these globals he's defined to look at left, right, up, down, and diagonal and all that. And then he does the flood fill again on those ones. So it keeps recursioning all the way down until they're all done, they've all been replaced, and then since it's a void, it just exits and they'll all be changed. So there's two ways to implement that algorithm, and one's recursive, one's dynamic. Another cool implementation of this is that we can use it for solving a maze, as you can see here. If you know the starting point and you have some endpoint destination, which is the only difference really you need is basically that same destination endpoint, and you need to not change the color. But if you have that destination endpoint, then you can just recursively use like a depth first search and just go down and see if you can get to that endpoint. And if there's a way to that endpoint, then when you come back up the stack through recursion, you can trace the path that your computer took to get there, how it decided to get there. If you always choose the right path first, then it will choose whatever way gets through it the most right, using right paths. So really interesting there, and it's just recursion again, and it's a depth first search, as you can see. And he just kind of returns true when in certain cases, and he never wants it to go out of bounds of the array, and I think that's why he does that. And yeah, it's really interesting. So a little bit background on the fill algorithm, or the seed fill algorithm. So the seed fill algorithm was created. The best we can figure out is, I found this article, Filler Up it's called. And it talks about how Dick Shoup created the first super paint system. And so we think it was him, and maybe Alvy Ray Smith, who helped out a little bit, or he made another one that was a flood fill algorithm for the next program. But we think it's Dick Shoup, and we also I found more information that he's got this area fill algorithm right here that you can see, and that's kind of what it's doing, right? It's an area fill. So that's kind of the implementation of it. And the reason why he made Super Paint was actually just to help with a television program. So he actually was helping with a kids program, believe it or not. So it's right here. It was for a San Francisco program. And he later used this for a NASA Pioneer Venus project mission. So I think that was to make technical graphics, so that's really interesting too. So some implementations of this in the modern world is they're doing more with it. They're trying to make it, do three-dimensional seed filling, like for videography, or for more graphics for like video games and stuff, as you can see here. They also they're using it to make soft shadows within an image space, so that was really interesting too, more computer graphics things. And I think they can use this for videography, for photography obviously, and for just all kinds of images. So there's lots of implementations that can be used for this. And that maze, like I said, solving a maze or something like that, it's interesting application. But the complexity of the flood fill algorithm is it seems to be n. So just the number of characters that you want to change. If you decide that the basic operation is when you change a character to a different character, or change the color to a different color, that's where your complexity comes in. That's where your basic operation is, and so you're getting an ON, a big O of n. Time complexity. And so that's really interesting. But yeah, I hope you really enjoy this program. It's a really cool program. I've really enjoyed looking at it and researching all about the flood fill algorithm. There's just tons on it, and some people, you can even use it just to find the amount of area of a object. Here's an example where they do an exercise on just this CodeCamp website, and they try and find the island's area. There's tons of applications, and it's still even being used today, and they're still trying to make it even better, for better use. So yeah, just want to thank you for listening to my project, and hope you enjoyed it.